The research I'm going to talk to you about focuses on primary succession after glacial retreat in the Cordillera Blanca, a mountain range of the Peruvian Andes. Have you ever wondered about modern glacial recession? Think the Peruvian Andes are a stunning case study for tropical glacial landscape change? You should, and let me show you why. Glacial cover has changed drastically over Earth's history. However, the melting that we are seeing now has occurred at an unprecedented rate due to human-induced warming of global temperatures. In the face of climate change, we have seen dramatic glacial recession, but the story doesn't stop with polar bears and ice caps. Tropical glacier ecosystems are also experiencing change. First, some background on the study site. Huascarán National Park is located in Peru. The park is 3,400 square kilometers, encompassing most of the Cordillera Range. The park contains some 25% of the world's tropical glaciers, and their melting has led to observable land cover changes. As glacial ice retreats, it scrapes across the ground, leaving a rocky, barren substrate and sometimes a layer of fine glacial dust. In this ecosystem, the barren land cover is eventually colonized by puna grassland species through primary succession. Although primary succession following deglaciation is typically slow, we may expect an accelerated rate of colonization by grassland here in the tropical climate due to the year-long growing season allowing for increased primary productivity. The question is, given the potential accelerating factors, does the primary succession land cover change keep pace with the rate of ice melt in this ecosystem? The consequences of these types of landscape ecology style shifts are poorly understood, but this kind of research question can be used to inform management of glaciated ecosystems in the face of global climate change. To assess the question of land cover change, we use the ArcGIS mapping program and satellite data of the park for 3 comparison years: 1987, 1999, and 2010. We can see in the GIS map comparisons that, as expected, the area of ice, seen in blue, shrinks over time. A closer look shows that the area of barren land, indicated in brown, increases and then decreases, but remains higher at the end of 2010 than it was in 1987. The percentage of puna grassland, seen in green, decreases first and then increases to more than it started at in 1987. This indicates that puna grassland is indeed colonizing newly exposed barren land quickly, but not more quickly than the ice melt over the average of the 23-year period. Colonizing like this. Why is this important? The impact of knowledge about the pattern of ecological change following glacial melting is applicable to larger and larger areas of land as glaciers recede worldwide. Development of this type of ecological understanding can impact and inform how we manage these ecosystems in places like national parks, and in turn impact the people who live in and depend on these ecosystems. Thanks for watching.